different each time. He sleeps for 12 hours.
So I'm just thinking it's
Plenty of people out here. Plenty of people here. Wow.
I think they are coming for one topic.
And which one is lower one? Okay. Hey. Do you need a minute or can we just start?
No, we can start.
Okay. Good evening. Thank you for coming in such masses. Hello. You wouldn't believe it, but it's still meeting time. It's not evening just yet. Don't drink beer. Listen. So this is the RADEXT working group, 1 hour slot from 1830 to 1930. And again, thanks for coming in such masses and not leaving the room. Thank you. Okay. So we should get started first with the note well. Please note well the note well. And then let's see it. Take a look at the agenda for the agenda bashing. We'll spend 5 minutes on the preliminaries as usual. There is a document status update where we see how far our documents have come. We have 2 active working group drafts, which get 5 minutes each for a very small recap on the current status. Then we have actually 4 individual drafts to discuss, or actually 3 drafts and a draft to be. So we actually have plenty of new work which could be incoming into this working group. And then after the wrap up, we still have 5 minutes of leeway. So we might actually spend a bit more time on one topic. Let's see how it goes. So first of all, for the preliminaries, we need a minute taker and a JavaScribe. Surprisingly, I didn't get any upfront notices that somebody is volunteering. So now is the time. Anyone willing to take notes? Hey.
Oh, Alan, thank you.
Alan is taking notes, wonderful. And a JavaScribe. No JavaScribe.
Done within 30 minutes? Because I believe at 7.
Start and then we will see. I don't even know if there is someone on the Java room.
Alan is here, so he's usually our chronic Java guest. Okay, so then let's start with, we have not published an RFC in the meantime, but we do have one document in the RFC editor queue. That is the larger packets over radius, for radius over TCP from Sam Hartman. This is actually in auth 48, so this should be out the door anytime now. And I'm hoping that this is kind of next week or so. So we have an almost RFC at this point. There is nothing in IETF last call, but we do have 2 documents which are currently in the IS2 processing state. There is the radius extensions for IP port configuration and reporting. This is publication requested, and ISG is doing its magic on it. And then we have data types in radius, work of Alan de Kock, and there is one AD review from Kathleen Moriarty with 2, dare I say, fairly minor comments. So I think we can push this forward.
Yeah, and I'll get to the other one very soon. I am sorry I had tried to get it done before this meeting, and I was not able to.
No problem at all.
So this is Alan. I actually put in a couple of those comments and pushed out a new doc earlier today. So I think that should be all right. We should. Sorry. Yes, these mics have that issue. I put in the minor comments earlier today and issued a document. So I believe we're okay for, barring AD review and timescale, we should be okay for working group last call and publication. We've done working group last call.
Yeah, I think you meant IETF last call.
IETF
right?
last call, yeah. Yes.
Okay, so basically we're ready to push the button on this one then. That's actually quite good. Now, in terms of active working group documents, which are still in the working group stage, I think I've completed all my Shepherd write-ups, and just as well as Lionel, so there's nothing in that queue. We have a document which has completed working group last call at least once, and that's the COA proxy. There is another working group last call ending next week. This is basically only to give Peter Deacon a chance to revoice his comments, which he had a long time ago. So with this newest draft, if there is no incoming comment, basically, we should be done with that, and we should be proceeding to the write-up at this point. So everybody who wants to comment on this document should do it really soon now. Another document we have in the queue is my own, the considerations regarding the correct use of if response identity. I've discussed a new version just before the cutoff, and I have a small slide deck really with just one issue on my side that should be remaining. And I hope we can put this forward at some point soon. Now for the new work which would be coming in, this is actually quite a lot on our plate, and we have to decide at some point which of those we want to adopt as working group drafts. So one draft is pretty much set as soon as it exists, and that is the radius over TLS, let's call it BIS document. The current RFC 6614 is experimental and also needs a bit of a refreshment for TLS 1.3. So Jim has kindly volunteered to edit that document, to be the editor. And so let's discuss it today and at some point see a draft about it. Then there is LoRaWAN authentication in Radius. LoRaWAN is this low power radio wide area network, and they have their very unique authentication needs. And there is a draft 01 also submitted just before the cutoff, which describes how to authenticate with LoRaWAN. And at some point, from looking at the document, at least some new Radius attributes would be needed, and maybe some reshaping of how this is actually going to be done. So again, there is a presentation here, and we well, should listen and comment. The next one is Radius extensions for network-assisted multipath TCP. There was a presentation about this on the last IETF in Buenos Aires for those who were there, which was not a few, not a lot. So there is no new draft. I also didn't get a presentation slide deck, but this is on the table today because the authors have indicated they would really want to have this as a working group document. So I guess we should discuss about the fate of this one. Then there is, as a last document, the extended packet header for Radius, which is fairly new. So this is an OO submitted also just before the deadline. And yeah, so let's see what this is about.
Based on discussions with Jim and Bernard and Stefan this week, I suspect there may be another document which would be useful, which would be Radius proxy considerations, which is really a bit different than the TCP or TLS document. And it's what do you do when you cross protocol boundaries, or, you know, what do you do when you have layers of proxy chains, just again, expanding things which are not documented now or poorly implemented or unknown.
Yeah, so first of all, thanks for sparking off the discussion on the mailing list already on this. Since we have 5 minutes of leeway in the end, probably we can just talk about it at any point. Okay, so let's first discuss these active working group drafts. We have the COA proxy document. I gave it 5 minutes. Actually, there's not a lot to talk about. So I'm also happy if you just take 1 minute for it. Let me just pull up the slides, and then let's see how it goes.
Yeah, just go through the slides. There really isn't much changed from the last IETF. Proxy spoofing can always be done. You know, the proxies can do anything they want. Peter Deacon had some comments. I'm not entirely sure what he meant by them, and I did not get clarification. So barring clarification, we can go with the document as is. Go ahead. So there were updated text. So the main issue is that the COA server, which is really the NAS, must treat all attributes as mandatory. If it doesn't understand it, it sends a COA NAC with an error cause of unsupported attributes. The issue is there are attributes added by proxies on the outbound path, which really should also be sent on the inbound path. But you want to delete those attributes before they get to the NAS because they're proxy signaling attributes, not NAS attributes. And so the discussion here is trying to come up with text which says, by and large, anything proxies add outbound, they delete going back. So when the packet gets to the NAS, it knows nothing about any kind of proxy stuff. I mean, what I've seen in practice is the proxy state attribute going from a COA client to the NAS, and then the NAS going, I don't understand proxy state, and sending a COA NAC back, which is dumb, but you could argue it sort of makes sense from reading 5176. So this is meant to be future-proof too. Simple, hopefully understandable. So all attributes added by a radius proxy when sending packets from the visited network to the home network must be removed by the corresponding COA packets from proxy from packets which travel the reverse path. So the NAS only ever sees attributes that it sent upstream or that the upstream is intending to send to it to do COA.
Yeah, my only question is if this is really foolproof in the sense that the authentication path could be different from the COA path, so you don't necessarily travel by the same hops. So you don't know what you have to remove because you never actually saw the packets.
Yes, the document has some other text about, you know, we sort of assume that there's mostly a one-to-one mapping between the upstream and the reverse path, and that the upstream proxy can talk to the COA proxy, which sends things backwards, right? If the paths are completely different, then who knows what the hell goes on, right? It's almost impossible to know. Some of Peter Deacon's comments were that the COA proxy did not talk to the radius proxy and was incapable of talking to the radius proxy. And I think the answer to that was, well, then I have no idea how to do any of this, right? If you assume that they're tightly coupled, then it's straightforward. If you don't tightly couple them, please write a document suggesting what to do. And he didn't, so it's a use case that I don't know how to solve.
Yeah, okay.
Okay, I think that's it. Next slide, but I think that's it. Any questions? Well, there's all the explanations. So any questions, comments from the room? Everyone's happy or overloaded? All right.
Just one question regarding the first comment regarding Peter Deacon.
Yeah.
So you are expecting what from him, or?
It would be nice to get an explanation as to what concerns he had and how they could be addressed.
Okay. So at least we can say that on the mailing list and saying that if there is no more comment, we can move on. Okay.
Yeah.
Okay, thank you. So the next presentation is then actually my own, so please hold on a second. So, yeah. So this is a short status update about the e-response identity, which has gotten a fair bit of discussion last time, but I hope we were able to solve all these issues. So next slide. If you do look at the Buenos Aires slide deck, there were 6 issues which came up on the mailing list and which we talked about extensively. I've basically fixed all of those. In addition to that, I promised in the Buenos Aires meeting I would do some ASCII art to describe the use case behind this a bit better. Actually, I didn't do that yet. So there will be another ref with just the ASCII art, basically because I hate it and have to find the willpower to actually do them. I have put something in this slide deck here to explain this, this use case, though. So this flows into ASCII art really soon. The real discussion point I have now with it is now that I've wrap my head around these use cases about when are multiple credentials available. The text has done some acknowledgement of the identity selection hints in the EAP RFC, which some thought could fix the problem in a more easy way. The more I look at this, I believe the identity selection, well, it's actually not implemented pretty much anywhere. And if it were, it only has 256 bytes to transmit identity information, which is way too few to be useful. But even if it were sufficient, it still doesn't solve the problem. So I think the text about identity selection hints can basically just go away because it doesn't contribute to the problem solving, or explicitly say it doesn't help. Now, the reason why I think that is on this next slide. And this is here, this wonderful SYARD. So the use case basically came in prominently with the new Wi-Fi line specification on Passpoint, or also Hotspot 2.0, depending on how you want to call it. Both names exist. So let's assume the user has a device with a SIM card in it, and the operator has pre-configured the device so that it authenticates with the SIM card to cellular networks, just like as usual, but also that it is allowed to use all Wi-Fi access points which have Passpoint enabled and indicate in their beacons support for this specific MNC-MCC combination. That's just a config item in itself, and there's nothing wrong with that. The user from that device also has a credential for a other roaming consortium just for Wi-Fi. Let's for a moment assume it's the EduRoam roaming consortium, and he has a config pushed into his device which says, okay, you can use this credential for the Wi-Fi network with the SSID EduRoam, or for any other Wi-Fi Passpoint network, which indicates support for the roaming consortium identifier. And then there is this 5-byte identifier, which is basically EduRoam. So at some point, the user comes to a EAP-protected network. There is an authenticator. And since he has different usernames for those two credentials, the one is 3gppnetwork.org and the other is whatever it is, at some point, the authenticator has to decide who can authenticate this user. So should I send the EAP requests to the EAP server at the cellular network doing EAP aka prime, or should I send it to the radio server of the EduRoam consortium doing EAP TTLS? Nothing wrong with that. So the trouble starts when the authenticator, next slide, actually is an access point which has both criteria enabled. So let's say this is a Wi-Fi access point with an SSID that is foobar, so it's not relevant here, but it indicates you are allowed to connect to me if you have a SIM card with this specific MCC-MNC combination, and you're also allowed to connect to me, and I will authenticate you if you have a credential with this Passpoint consortium identifier. Now the device looks up its local config and realizes, gosh, actually I have an AKA credential and I can use it because I have this cell phone provider in my list. And I also have a TTLS credential, and I can use it because I have this consortium identifier in my list. So the client configuration simply knows it has the choice to use both. At some point, it has to try one. If that doesn't work, it tries the other. The important thing is, and that's what the document is all about, when you try both, always use the realm identifier, which matches your actual user identifier. So don't just magically assume that you can send one realm identifier and it will try both EAP methods in a row. It just can't do that because the routing, depending on the realm identifier, might put you into a place where only one of those will work and the other one will never be tried. This is the basic problem space we are working in, and actually it could exist also for wired networks, but these use cases are a bit more special. It's basically everywhere where the authenticator cannot or indicates more than one possibility to authenticate. Now, the problem with the identity selection hints is if you put into the authenticator, into the Wi-Fi access point, the identity selection hints, it simply does not help because the Wi-Fi access point would send in the EAP request identity, well, you can use this or that. And the choice for the client is not narrowed down because, well, they're both usable, so they can both be indicated in this message. So it just doesn't contribute to the problem that the EAP identity selection hints exist in principle. So since they don't help, I would prefer to redact them out and just say, okay, that's it. And that is actually the one issue I have. So I wonder what people think of that. I would like to push out a new ref with ASCII art. And then I hope that the document has gotten enough beating that we can actually move forward to a working group last call.
Thank you. So this is Alan. I have a question on, oh, that's better. Is that better? Yes, okay. Mics are confusing here. I have a question on implementation. So how much does this change existing implementations, and who has to do this? And are all the access point vendors aware they have to do this and are on board with it?
So this is a bigger question than just the EAP supplicant side. What I can say is that the major Wi-Fi access point manufacturers do implement Passpoint these days. So you can just buy new Cisco gear and or any other vendor. And it will have a config option to do that. Implementation quality, as always, varies. We have seen that all the major OS vendors on the client side also indicate support for Passpoint. So you have Microsoft Windows 10, there is OS X, iOS, and even Android in its newest version has the APIs to configure Passpoint and react upon beacons with Passpoint. So in principle, the infrastructure is there. Actual deployment, I don't know. We are looking at this in Jerome, especially on the client side. The implementations also vary in quality on the lower end of the scale. So we're not quite happy with what we see there, but it is a problem that can come your way anytime. And if I could add, actually the reason why I realized this issue a long time ago was way before Passpoint, was basically an ignorant EAP supplicant manufacturer in a mobile phone, which basically said, okay, you can have as many EAP credentials as you like, but as soon as you come in the vicinity of any Wi-Fi access point, I will try my EAP AKA credential first, and I will always use the realm identifier from 3gppnetwork.org. So we actually had customers in Jerome who said, I've configured my mobile phone with the right credentials, I know my password is correct, but for some reason, it never actually authenticates. And that is because the routing of the request always consistently failed. Luckily, that manufacturer has moved to Android meanwhile, so their own implementation is gone. But back in the day, I thought I could just approach the manufacturer and tell him, look, you're doing EAP wrong. But it was never mentioned as explicitly as it could be that this is not something you should do. So that's what this document is trying to fix.
Yeah, this is Lionel. In another way, would it be simpler to say that it is assumed that the username, the identity used in the as a username will be relevant enough to figure out which realm to address? And how to do that? It's not so relevant for this document. It's something that you can put, I think, simple text to say that it is something to take into account, but we have the same issue with diameter anyway.
Yeah, so the document already says it's up to local configuration how to split the, realm identifier, which is the EAP response identity, and the actual user identifier, which is whatever the EAP method uses as an identifier. How you do that UI, how you ask the user, how you configure this stuff.
Yeah, so actually from my personal point of view, not as a chair, but as individual, I think it's enough.
Okay.
Jim Schad. Okay, so I understand how to deal with issue 2, and I understand how to issue number 3 in your next steps. Having a bit of problem with 1. You've described a problem, and I will admit I'm tired, so I may have dozed off and missed exactly what the options are for the solution so that we can converge on the solution. At this point, I'm kind of at this, every time I hear this, it's like, we have a problem. It'd be nice if client configuration could fix this. It'd be nice if client UI could fix this, but we really don't know what to tell clients what to do on this. So we don't really have a solution. It's just kind of client devices should just keep trying things until things become happy?
Well, it's not actually something that needs fixing in UI. The UIs I know actually allow you with your EAP method to select which outer identity you use, what we call realm identifier meanwhile. So the UI-wise, everything is fine. The problem is much more with the EAP state machine. And if you have locally configured more than one realm identifier, well, you have to restart the EAP state machine after you failed with one credential. And you just don't run one EAP state machine for both EAP types. That's not enough. You have one EAP state machine for one EAP type. If it doesn't work and you want to try the other one, start fresh with the new realm identifier that matches the other EAP type, and then use that. So it's pretty much, yeah, backend code in the supplicants. It's nothing to do with UI or changing configs. The only config change you might want to have is for privacy considerations. If you want to manually order your EAP types in terms of preference, then the EAP state machine, as it goes along, should honor that. That's the only change.
Brian Wise, Cisco. I'm a little confused on the privacy situation. So first comment is the draft says, you know, identifiers will be revealed, and then it says when privacy is important. And actually, we're in an age where when we're developing protocols, privacy is always important. So that's not a very good statement, actually. We should be designing otherwise. Now, the question is, in this example, for example, that you're showing, will the client device try to use both of his credentials all the time, or just when he sees certain pass points or other indicators from the network, he'll only use the ones that match? Which one is it?
Yeah, so this is the situation where he only tries a credential if he knows it's going to work on this particular criterion. The other story I told many years back was just ignorance on these EAP applicants. He just did that despite having no information.
I'm sorry, I just couldn't quite, it was some echo, I didn't hear exactly what
you
said.
So this is actually the situation. The EAP type is only tried if the local config says it is good for this network, yeah.
Okay. So that's not so bad. I mean, at least he's only responding when he's getting some kind of indication. Now, of course, the network could, or an attacker could lie about that, but it's a little better than, for example, when we cycle through all the SSIDs on our device. But I would just suggest maybe making the privacy statement a little bit stronger in that section, and explaining maybe, you know, where there's better protection or not. I mean, it does say that if you use the latest EAP methods, you're also somewhat protected, but I'm not sure you're protected against an active attacker, but maybe you're protected against a passive attacker then. I don't know. That should be maybe made more clear.
Yes, I'm all for making the privacy statements more rigid, no problem. Basically, for many EAP types which are in use today, like TTLS, PEEP, and so on, these privacy extensions do work. We have some EAP types where they don't. So EAP PWD, the Dragonfly thing from Dan Harkins, basically has no possibility to hide the real user identifier. So that's why the draft says, so if you have these EAP types, try those last, because, you know. Okay. So this would be it. These are actually the two only drafts we have to work on actively as a working group at this point. So here's the new work, Jim Shad, for the RC6614 BIS document and TLS 1.3.
So when I volunteered for this, I said, oh, this will be easy. No problems.
It always is, right?
Yeah, I mean, I know exactly what needs to be done here, and it's easy going forward. Okay, so next slide. So then I, of course, reread the documents with an eye towards actually editing them and said, oh, well, there's a couple of issues that I'm not exactly too sure how to progress. And there's a couple of issues where I'm not too sure which documents to progress. So I'll cover these things, but we can get some guidance. We can figure out which documents we actually want to rev, whether we want to combine some documents together while we're doing the revving, and see what happens. So there's a couple of nice, simple, top-level topics that need to be covered. How do you trust things? What do certificates look like? How do we want to actually say you should use tickets, whether you must use support tickets? There's some real advantages in doing so. There's some interesting questions about transport layers and how things work or don't work in terms of who does things, what things do, which transport layers we want to run over. And then there's some really fast TLS option questions that we may want to think about documenting as we go forward. Next. So trust modes. Basically, there's 2 trust modes that are essentially laid out in the current document. The first is to say, oh yeah, well, using CA infrastructure, they're relatively cheap, but they're kind of hard depending upon what sort of system you're setting up to get everybody to buy into the same infrastructure. There's of course the pre-shared keys, which is basically how Radius is set up today. You could continue to do that, but of course that's manual configuration and gets to a real mess in terms of trying to configure it going forward. There's a possibility of using Dane and maybe doing some lookups in terms of trying to establish, is this the right cert to be used? But that still doesn't actually solve the problem of, do I trust the entity that is the subject of the cert? So it's like, yeah, this is the certificate that's associated with foo.example for the domain, but I still need to make a decision. Is foo.example a domain I'm willing to talk to? And is the answer that they give back going to be an answer I'm willing to actually use in terms of doing things like granting access to a network and things like that? I actually briefly thought about the whole question of, should we include the DNS lookup stuff in terms of what's in 7585, and personally I'd actually just rather bury that in the sand and let someone else deal with it than put it into this document. So I mean, obviously we need to document the first 2 in terms of how to do things. I don't know how much we want to document Dane or not document Dane in terms of establishing trust in certificates, since it doesn't actually really solve the problem. It merely kind of says, yes, you have a certificate that's real, but it doesn't say anything about whether you should trust the entity at the other end. Okay, next. Certificate profile. We should probably actually talk about what certificates, what should be in a certificate that is used for Radius. And a lot of that is pretty simple. We don't currently have one. Policy OIDs is certainly one way of establishing whether or not you think that a particular certificate is useful. Another thing is extended key usage is often the times used. There's a few other things we need to talk about, which is things like, so what sort of naming do we need to put in certificates? Do we put in DNS naming? Do we put in IP naming? Do we put in something else that is URL based or in realm based, NAI something or other, which would just be kind of, please no, spare me. So most of that stuff, I've got some ideas in terms of how to go forward and push. So I'm not immediately too worried about these things. Next.
Oops, sorry.
I thought I talked about that already. Tickets. TLS 1.3 is making tickets and a whole lot more useful. I mean, they exist in the current systems, but with 1.3, they just become extremely useful. So basically what you can do is you can go through the full validation process, send a certificate, generate Diffie-Hellman keys, do your client verify, do your certificate verify, and then say, oh, and now that I've sent you the first message, give me back a set of tickets. What that means is the second time you hook up, you say, here's the ticket from when you validated me last time, and here's the pre-shared key that we used on this, and we don't have to do anything about sending certificates around because we already know the answers to all those questions. So basically, you're really reducing reconnect time or setting up a second channel if we basically say, yeah, you have to support tickets. And that's potentially a huge win just because you save the cost on certificate validations on both ends. Next. So this is basically a real fast look at some of the advantages you get with TLS 1.3 in terms of the handshakes. This is kind of a really scaled back version of what things look like, so that if you do pre-shared key, the application can actually send encrypted data along with that message. So this says that not only if I use tickets and do reconnect, do I not have to go through all the certificate stuff, I'm actually going to send my request up on that first message, whatever that first set whatever that first radius packet is. So I'm really reducing the number of messages I'm sending between the server and the client and radius by doing this pre-shared secret ticket resumption, because I'm sending that message up the first time. I'm still actually saving things in terms of if you look at the difference between 1.2 and 1.3 in TLS, because in 1.3, even if you go through that full certificate validation, you can send encrypted data up on your second message. Whereas in 1.2, it's the third message that this client sends out that they can finally send encrypted data. So in any event, you're saving one round trip, and you're potentially basically not having any round trips on your encrypted data with the ticket resumption if you set up parallel TLS ports. So next. This is where I started getting into the funds of which exactly documents are being revved and who needs to rev them. So if you look at it, the TLS over TCP actually came as two documents. The first described what to do with TLS. The second described what to do with TCP. The TCP
6613 was TCP. Yeah. So you said the first one was TLS, the second one was TCP. It's the other way.
One did one did the other. And if you look at radius over DTLS, that was another document. So both of those documents are experimental documents as well. So at a minimum, if we want to do the TCP over TLS over TCP, we probably need to rev the TCP document. It's unclear at this point how many people care about doing DTLS. But it's possible we want to rev that document as well to get it up from experimental to standards track.
So this is Alan again. I believe there are a fair number of people using DTLS to connect their 1,000 hotspots access points to their central controller, but not many people use it across the public internet.
And which implementation are these using?
It's pretty much 100% RADSec proxy.
And over here, we thought nobody uses RADSec proxy in DTLS mode.
And when I sent a message to Alan back in May saying, I'm kind of interested in these things, one of the messages he sent back just caused my eyes to glaze over, since I'd actually never heard of SCTP, but it's something he was saying, well, maybe we should look at this as a transport layer going forward because it has some interesting characteristics that might actually be useful in terms of avoiding some of the things like headline blocking on TCP. The other thing that I immediately started running into problems as I read these documents was trying to figure out exactly what was supposed to happen as you went between boundaries of these things, and who was doing resends, who was not doing resends, why were people who were doing resends. So the TCP document says, hey, this is a reliable transport. You never do a resend because it's reliable transport. That works great right up until you say, I'm doing TCP up to this proxy, and from that proxy to the actual server is UDP. Okay, now all of a sudden, who's responsible for doing the replay? The NAS isn't going to do it because it thinks it's talking to reliable transport. The proxy is not going to do it because proxies don't resend. So the answer is nobody does it. That's probably not a workable answer. The other world would be if the NAS starts on UDP and it goes to a proxy which converts between UDP and TCP, the NAS is going to start potentially hammering that reliable TCP channel with retransmits because things are timing out somewhere down the line, maybe because nobody wants to talk to them. But that's additional traffic on the TCP channel that doesn't actually need to be there because, well, you got that far, and it's somebody else's problem beyond that who's reliable. There's also some interesting questions that come up in terms of the big message stuff that went through. It may be very nice if you go from UDP to TCP and TCP to UTB to reassemble those big messages. So it's basically, on that first UDP hop, I can confirm back real fast, get the entire message, send the big message over my big TCP pipe, which may actually end up going straight to the server and save a whole lot of round trips on the server's behalf. So that's useful.
You're using
Right.
Avatar.
Oh, sorry, next. This isn't all that interesting. There's a whole slew of possible set of things that can be done. Next.
Okay.
So, question is, which documents need to be done and revved, and am I going to rev all of them, or some other people going to rev them? At a minimum, I think we need to biz the TCP document, or else wrap that into the TLS document.
Okay, thanks. Maybe one quick question, but we're running a bit over time, so. No? Okay. So the next one would be the LoRaWAN draft.
Yeah, hi everyone. I'm Arun. I'm one of the author of this draft, and this is 0.1 version of the draft, and we got some comments for the 0.0 version. So the main motivation of the draft is to include the existing AAA infrastructure into the LoRaWAN infrastructure for authentication. So next slide. So this is about the LoRaWAN, long-range wide area networks, and we have some impressive numbers. It's taken from the LP1 buff. So here you have a point. Here we have the end device, and this is the NAS or network server in this case, and the end device communicates to the network server through the radio gateway. And this is actually the picture from the BOF, but actual available LoRaWAN specification doesn't have the joint server. So all the authentication is taken place from the network server point of view. So and initially we have a pre-shared key between the end device and the network server. And after the joint procedure, we have arrived at the session keys, so which are used to decrypt and encrypt the communication between the end device and the network, or the end device and the application server. Next slide. So our motivation is to replace this joint server, which was actually not in the current specification, but to replace it with AAA server, and the network server communicates with the AAA server with the radius protocol. Next slide. So why AAA? I mean, as you know, that it's battle tested and it's deployed in the wild since years. Example, Ready-Roam, and it's also scalable. It's suitable for the Internet of Things, and it's federation aware, suitable for roaming. Next slide. So I'm going to take you over the current procedure, which is used in the LoRaWAN. So we have the commissioning, which means that app key, which is the pre-shared key between the end device and the network server. And also we have the dev EUI, which is unique to each of the device. Next slide. So the device sends a joint request with some kind of a nonce along with the dev EUI, and app EUI to the network server. And the network server, after verifying the credentials, that means app key, so it sends back the joint request, joint accept, and this device can be able to derive the session keys later on. Next slides. So this would be the contents of the request and the response. The main fields to note here is the app EUI, dev EUI, and nonce. App EUI is more specific for the application provider, and dev EUI is specific for each of the device. And the nonce is created by the device itself. And in the response, app nonce is generated by the network's server, and net ID and the dev address are also generated from the network server. So here, the request is sent without the encryption, but attached with the MIC, that is message integrity code. But the response is always encrypted from the network server. So the end device can decrypt the response with the help of the app key.
So the app key makes the message integrity check.
Yes.
Okay, so
we calculate the
you
mix
basically
based on
sign
the
with
app
the
key.
key.
Yes.
Mhm.
So next slide. So these are the keys which are involved in the authentication part. The app key is pre-shared between the device and the network server, and the network session key is used or is derived, and it's used to encrypt or decrypt the commands or MAC commands between the network server and the end device. And the app session key is used for the application specific data. For now, it's both the keys are residing within the network server. So can you go 2 more slides? Yeah. So our proposition would be to include the Radius server, which actually does all the jobs of the network server, and we exchange the keys through the Radius attributes. So so in this case, the the app session key, we have put 2 stars, which means you can decide to send back to the network server, or you return it, and you can share it with the another application server through another interface. Next slide. So we plan to introduce these 4 new attributes in the Radius, and we consider the RFC 6218 or 6614 for maintaining the security to transmit the keys over the network. Next slide. And one open issue is that we have this app EUI from the end device, and we need to have some kind of a methodology to map it with the application owner. So we need so basically, when the network server or network access server gets this request, it has to check the realm of the application owner and use a DNS query or something like that to send it to the appropriate Radius server. So one such solution which we found was 7043, but we need to do the inverse of this thing to make this happen. Next slide. I mean, we implemented actually a proof of concept. We run the Radius implementation in Go language, and probably we are thinking of implementing using the free Radius for the LoRa. Next. Thanks for everyone for the comments, and that's it.
Okay.
Question? Comment?
Okay, well, then I have one. Basically, this slide here says you send an access request and you pack the entire join requests bit by bit into a single radius attribute. The content looks like this, and that's pretty much structured data. So we have multiple subfields in one radius attribute. We don't usually like our attributes that way.
Yeah, I mean, we can also decide each of these parameter into a different radius attributes.
That's what I'm getting at, yeah.
Yes and no. I mean, I believe it's 6158 that says where there are data structures pre-existing elsewhere and transported by radius unmodified, you can just transport them as is.
The thing is, basically the radius server needs to tear those apart to do all the key calculations. So it needs some kind of business logic here.
The reason why we try to send without modifying anything is that at this point of time, the network access server doesn't have the access to the app key. So you have the MIC calculated based on the app key.
Yeah, but you get your integrity protection using radius shared keys or whatever you use. So don't think that would be an issue. Anyway, for example, the device EUI, that's basically a MAC address, if I got that right.
Device address, yes.
We usually call this calling station ID, and the attribute exists already. So
Yes and no. I mean, my 2 cents as an implementer, in some respects, it would be easier if this was all just radius attributes. On the other hand, I do have a loathing for re-implementing things multiple times. If there's some kind of library which already does all of this, and I can just link to it and pass it a blob, then I'm happy, right? And it's much easier. The more complicated issue is, what policies do people want based on this? So if people are going to say, if the net ID is this, then respond with a different radius thing, or if this other lower ON field is that, then do it something else, then it would be more useful to split them out into radius attributes. And at this point, just use TLVs because it works. So it's a matter of what the use case is. If you expect this to be transported as is and not really examined by anyone other than a little bit of crypto dedicated to this protocol, it's probably okay to transport it as is. If the radius server needs to do things based on the contents, you probably need to break it out.
So, yeah, as a chair, so we're not responsible for defining the functional solution. So, from the LoRa point of view, is there any expectation to have such kind of a solution based on radius, or it is you are trying to proposing something that could be afterward accepted by the LoRa community? How do you see the rest of this work, assuming that this work is agreed here in this working group? Usually in this working group right now, so we're responsible for the definition of the protocol, but not how this protocol is used by others. So it could be other working group inside the IETF or in other SDO. So actually, we will work on this only actually if there is an existing requirement. So I was wondering, what is the current expectation from the LoRa community on that?
Right now, actually, we have not yet formed the LP1 group yet. Maybe down in the future. I'm not sure about that.
I have a comment from the driver. Dan Garcia says, I agree with Alan. We agree with only one attribute. There will be an implementation that processes the message as is.
Thank you.
We had a meeting on Sunday, a technical meeting on LP1, and we have some people that say that it was a good idea to implement these kind of things.
Okay. Because I think that the most important part for us from a RADEXT perspective, IETF perspective, is to ensure that there is the support and some requirements from this community to be able to develop that. whatever. I think that from a technical point of view, we can discuss, and especially the link between what's come from the LoRa and what you want to export to a radio server. But I think that from a protocol, it could be straightforward. We just need to agree on the set of attributes. I may have also some concern about that and the way the attributes are defined. But the most important part is to ensure that this work will serve the LoRa community. If not, we will not be able to say, oh, from the IETF point of view, we're seeking that this is the best solution. And I think what would be at least required from a problem statement point of view, it's to consider the different cases that you may have regarding the location of the AAA server. If it is expected to have multiple players, if it is the same kind of during the both on LP1, there were some discussion about roaming, for instance, but I don't really know what is the current requirements regarding the roaming. So I think that this kind of stuff could first of all militate, or I don't even know if it is English, but actually promote the use of a AAA based infrastructure, and obviously for a radio server in that case.
Mm-hmm. Okay, so one quick question from me: is the lack of radius attributes and the lack of an RFC here holding back LoRaWAN in any way? So is this urgent work that doesn't allow you to continue?
Yeah, it would be great if we have these radius attributes defined already.
Yeah, but you said earlier that the AAA part doesn't really exist, and right now the keys are validated.
Right now we don't use the AAA. They do everything in the network access server itself.
Okay, so the standard as such is working already. You just like to extend it.
They have a discussion about using this JSON tunnel to communicate with the joint server or something like that.
Yeah, actually, if I understood correctly, the joint server doesn't exist.
Yeah, as of now, in the LoRa specification available to the public, they don't have the entity called joint server.
Okay, so now they want to integrate both type of server, and it's where there is a discussion.
Yes.
Okay. We need to move on.
Yeah. Okay, thank you.
Okay, so for the next one, there are no slides. I hope there is somebody here to talk about it. The multi-point, the assisted multipath TCP radios thing.
Nothing to say, or? Quick comment?
Yeah, no comment at all. Yeah, I have made the presentation last time. Yeah, the content of the draft didn't change since then. All what I like to say is that the content is stable. It adheres to the recommendation from this working group, and it's fulfilled the data type guidelines and so on. So it's just a request to consider this as a new short item of this working group.
Yeah, my question back then was, so is this actually being used? Is it useful? Because the use case didn't look very convincing, but is it part of any standard?
It depends what we call standard. The standard, in fact, which exists, but it is not a standard, but is an experimental track, which is IMPTCP itself, which is the protocol that defines the communication between the two ends that support IMPTCP. But the use case that we are targeting involves the CPE and another element which is located in the network, which is another IMPTCP proxy, which is located in the constant writer. And these two entities are not standard so far. As you know, here in IETF, it is difficult to standard the TCP proxy stuff, even for TCP existing networks, but there is nothing which is standardized. So there is some magic there, which is this IMPTCP proxy that will glue multiple paths. The first that will come from the wireless network, and the other one that will come from the wireline, and then it will glue this multiple path in order to increase the bandwidth which is exposed to the customer itself. So the purpose there is to increase the quality of experience of the customers, and also for the service provider to optimize them, because there are some lines, access lines, which are all increasing this one to support the new technologies is really CapEx and OpEx consuming, and there is a real trend today in the operator community to correlate multiple access networks in order to provide better services to the customers. The MPTCP itself is deployed today in various countries. For instance, in Korea Telecom, Iska Telecom, UG in Korea, there are three deployments today based on MPTCP proxy. There's another deployment in Turkey based on MPTCP proxy, another one in Belgium in Proximus, which is based on another MPTCP proxy. But each time they're implementing specific and proprietary solution to authorize the customer who subscribes to the offer to make use of this one. So what we are coming with this draft of the specification is to provide something which is standardized to allow for this kind of service providers to deliver the service to this customer. So MPTCP proxies exist in the network today, are deployments, but we want to go beyond the proprietary solution to have something which is more standardized. That's why we are seeking your help on this part.
But maybe based on this comment regarding the use of MPTCP, multipass, maybe you can try to convince people that it is a good solution and to at least express the interest for that on the mailing list. I think it was the basic question from Stefan, saying that I think that from the as I said for the previous document, from a protocol point of view, it's fine, and actually you are following the last recommendation. So I think it's more about interest about this, and if you at least if there is some people interested by maybe even if they are not used to, but saying that there is an existing requirement for such kind of solution for authentication.
I think that there are two questions. Yeah. The first one is the interest in MPTCP itself. I think if there's interest in MPTCP itself, it would be another working group which talk about that. I can invite people, but I won't do that because this isn't the purpose. Why I'm coming here? Because there is expertise about the Redis extension. So I think that's, for me, the core point is to avoid defining something which is completely disaligned what you want to see in the Redis specification. So it will be hard to convince the community in the Radix working group that MPTCP is good, etc. It will be good if I have that, but I am not hoping to see that, and I won't fight to see that, because there is no point there to do that.
This is Al again. I mean, my 2 cents is the purpose of RADEX is not just to extend Radius, but also to review and accept and authorize other people's use of Radius. And for one attribute, if the use case is clear, I'm happy with it.
It's partly true, because it's always possible to define, for instance, vendor-specific AVPs. The question is that when even if we have a lot of room now, from a working group point of view, you need to ensure that it's to answer to a request, but not only to someone, but to people that will implement this.
Yeah.
And it was not something against actually my colleague. It was more about to answer to the Stefan comment, saying that just to ensure that we are doing something that actually even may be used, but actually that may be useful for others.
Yeah, a related question is, if the rest of MPTCP is experimental, why not publish this as experimental? I mean, it doesn't necessarily require a working group draft. It can just be published with the RADEX group going, yep, that makes sense.
Yeah, and I think it was just to be able to figure out what will be the way forward for this document. So sorry, we are late. We will not skip the other one. We just to say that we will. So we'll be a little bit late. So the next one, maybe we can try to shorter maybe the presentation, but we'll have just time for some comments. So please.
Hi everybody. Yeah. Okay, I'm Anchor Chen from Cisco Systems. This is a joint work with my colleague Lemmy Shen from Cisco. So this is okay, I'm trying to finish in 5 minutes. So this is the problem, the statement. I think this is well known to folks in this room and to the working group. So this is about the one byte identifier field, which basically allows only 256 requests in flight. because that right. So the workaround as basically documented in multiple IFCs, and is to do the workaround. Basically, you create parallelizations using the multiple source port. In the case of TCP, of course, it's a true parallelization. Next, please. So the issue we are facing as a vendor, actually, as a reference. So I suspect that the problem is not unique. So currently, we have actually deployment. We have implementation and deployment that use hundreds of UDP sessions. In the case of wireless LAN controller, right? It's in the range of hundreds. And for the next generation product, the requirement is basically increase this performance by 10x. Okay, you can imagine now it goes to thousands of sessions. That gets, I think, very difficult. It's just so this is a problem that I mean once it goes to thousands of the sessions, basically you have a number of issues, right? You have a resource utilization, you have memory, you have CPU, you have the local port. Local port is limited, right? And you have efficiency issues. And in case of TCP, I mean, it puts a lot of load on your basically on the client as well as on the server. How many sessions can a server support? If this one client actually generates thousands of sessions, right? There's the operational, there's implementation and operational complexity. Next page, please. So here we basically look at this. Basically, it seems there's an opportunity really for us to actually address this. Or it looks, you know, I'm new to this to this Radius working group. I have gone through a number of documents. Looks like this the issue has been postponed, but I believe we have a time that we are at a point that this needs to be addressed in the protocol instead of doing workaround. So this is that's what this extension is about. Basically, we propose a extended packet header, basically to enlarge the identifier field. While we are doing that, we also it looks like reasonable to also enlarge the code field, code type, because that is 1 byte. I think we currently use about 50 some. So if we have a quarter, then we basically, to be future proof, let's do the header changes once and be done with it, right? So there's then the way to here the key for this in the proposal is to basically allocate a packet we call, I think in this working group usually we call message type, here we call packet type code. So as a carrier to embed actually a real packet inside. Then we use a capability basically to discover whether this server is supported, so it supports this functionality. Next one, please. Right, this is the extended packet header we are proposing. So the first, if you look at in the current standard header, we have the first byte is a packet code. So with that, we use the allocated one, special one, and then next one is a reserve field. The length is the same, authentication is the same. We have another reserve field, and then the code. If you look at code, is shifted there. It's like 2 bytes. Then identifies 4 bytes. So the semantics remain the same. So this why we have this reserve field. It's basically the concern is for the existing protocol analyzers, right? If we with this format, they can at least pass it syntactically, right? That's the reason. If folks in this working group feel that it's not necessary, of course, then we can reduce it, right? The reserve field, at least the other 2 bytes can be certainly can be reduced. All right, next one, please. So how would this work? Basically, you use the client initiate this status server message, right? With a new attribute, you basically to do the discovery of capability on the server. That's pretty standard, looks like, right? Another way, or if you know that the server is something that server supports you can do by configuration, right? So here, once the capability is discovered, always is known in advance, right? here in terms of implementation, so we recommend in the draft that we reserve the existing 0 to 255, the number space as for the standard header, because for Discover or whatever, right? And then for the larger numbers, you use that as a identifier for the extended header. Once it's discovered, you can basically exchange the packets in both formats, in the standard header or extended header. I think that's it. So what so what we like to do is this: we want to solicit feedback from this working group and to address the concerns, and also basically to get some operational implementation experience. Certainly from the Cisco OS implementation, and also with the open source, probably we go with the free Radius. Hopefully by next IETF, we have more implementation experiences. So we like basically address the concerns and spin the draft one more time. And of course, we want this, we would like to see the draft be adopted at that.
Okay, could I first make a note with my chair hat on? So this is actually a substantial modification to the protocol. We had a similar one just last week, basically, which is the larger packets for Radius over TCP. But that was experimental. It was over a new transport anyway, so these were all fresh implementations. What you have here basically requires all of the industry to update all their equipment, and that's a whole different story.
So here's I read the number of drafts. We have been thinking, we thought about this. It looks like actually the change is although conceptually it is fundamental. I agree, but the change is really limited to the header, the encoding and decoding. So I have looked at some code. It's look at my sense at this point is probably a few hundred lines of code change, because it's really limited in the section of encoding and decoding. Yeah.
So
but I don't have the concrete data, but that's just my sense. Yeah.
So this is Alan. Yeah, something like this has been needed for 10 years. Doing it is a whole other nightmare. As a point of information, there is at least one commercial Radius server which extends the identifier space via a VSA. They simply put a VSA into every packet, and the client and server have a configuration flag saying, allow this VSA, use this VSA. There's no negotiation, no nothing. It's 100% compatible with existing Radius. That might be simpler and would work without changing anything. So this changing the header, if you're going to throw out the header, you might as well throw everything out and start over from scratch, which sounds familiar. I think we did that.
But it seems we have with the Radius protocol, we have this discovery mechanism. That seems to be a nice way to deal with the backward compatibility. Right.
To be technical, the status server isn't really about discovery. It's been abused to be discovery. We have had capability negotiations in Radius going back 10 years, and everyone has run away from those because they're terrible.
TCP is the latest one that is abusing this.
It's capability negotiation in Radius.
Making use of it.
Lionel, as an individual, I think it's a perfect use case for diameter, I would say. If the idea is to change the header, if you can rely, I didn't investigate any solution for that, but if you can rely on attribute, it's okay. I think that if the real goal is to enable to have more than 255 or 256 concurrent operations, it's because you have a clear need to have something more, and the more in that case is diameter. It's not. I think it's where we need to take care about how to extend and so on. And as said by Stefan, if the consequence, even if it is simple from your point of view, to update the header and to modify all the client and the servers to be able to support that, it's a huge impact and on all the existing implementation. And actually, what we are trying to do in this protocol is to extend the protocol functionalities, but rely on something that anyone can decide to support or to ignore.
Yeah, but this really, I understand the principle. This really does not violate that principle, right? It's basically negotiation based. Yeah, right. So here, it's just a very, very practical challenge we have. Today, as I give the data point, in our implementation, we have hundreds. Now we are going to thousands. I mean, that's just I mean, to people who have not been associated with Redis, who have not worked, it sounds really, the first time we talk about this, sounds really silly. I mean, then of course we have a history, right? So it's just as Alan pointed out, it's this 10-year-old problem.
Just one small additional comment, and after that I will let the floor and we will close the meeting. But the point is that for instance, for diameter, it is said that it is used in mobile network and so on. It's fine. It's very expensive and so on. And the fact is that everything based on radius as it is today is fine for the current deployment and even future functionalities. Now, if we are saying that the protocol is not so fine, and we need also to modify the protocol itself, not only adding attributes to be able to support this kind, that is a key issue for you, as you are saying. I think it's always time to think about how to redefine also how the AAA infrastructure is used in such kind of environment. But that's all. And as an individual, not as a chair.
Appreciate it.
Yeah, my name is Naiming Shen from Cisco. So I was thinking this so-called fundamental change is still, if you don't support it, you don't support it, right? From our company point of view, if we have such a use case and we also have the server side of the support, and it's nice to do, although I agree to go to things like a diameter is simpler, but this is a protocol needs to move forward, right? If we keep delaying this thing, this issue is a real issue, never get solved, right?
So here, as a reference, so for folks who actually who don't know me, I have been involved in the routing protocol areas for a number of years. So we transitioned. I don't know if you guys paid attention. We transitioned the global internet from 2 bytes into 4 bytes in BGP. That is so fundamental, right? But it was done. It was done really nicely. Now the transition, piece by piece basis and backward compatible, and the whole world has transition. This sounds big, sounds fundamental, but it seems to me it's really the big in sense of concept at a conceptual level. Not my feeling is that as a protocol designer and also as a coder, my sense is that this is really a few hundred lines code change. I will get more data later. The next one.
Okay.
Yeah.
So I'm trying to find some nice closing words. So I think we all agree that this is a problem worth solving, and it's hitting the streets. So that's no doubt about that. Now you have a solution here which is a bit more heavyweight than what Alan told us about with the VSA, and I think we should all go home and think about how do we best solve this problem. Is it sufficient to, well, not have a VSA but standardize an attribute for the extended header or something, extended identifier? Or you do this rather big change. So I think our options are, do we apply the Band-Aid on one place or another? And is it a small piece of Band-Aid or a big piece of Band-Aid? The truth is radius is pretty much at its limits here, and we can't do without Band-Aid. So we have two less than perfect options on the table, I think. And yeah, we have to make up our minds. Yeah, please do that. Okay, so thanks for staying longer than we allocated anyway. No?
Blue sheets. Everyone on the blue sheet. Because I think it's the first time in a long time that 20 people. Is that working?
And for next time, I will try to allocate 90 minutes because actually we have plenty to talk about. So thanks for coming. Goodbye.
Yeah, this I have even not